So in our last few videos, we've been talking about linear equations and linear functions. Today, we're going to talk about a system of equations. And the difference between a linear equation and a system of equations is just that a system of equations is more than one equation. And it could be linear or it could be quadratic, it could be any type of function. We are going to only talk about systems of equations with linear equations. Okay, so what does this mean? I want you to think about two planes that are in flight, and each one has a separate path. Now, planes actually pretty much follow a linear path. It's actually kind of trapezoidal. They make their ascent, they stay at a certain altitude, and then they make their descent. So they don't move up and down a lot. That doesn't actually happen. These two planes, I want you to think about making the air traffic controllers, right? So the air traffic controllers are consistently checking the paths of these two planes to make sure that they don't intersect. So a system of equations can become very important because we want to make sure that we know when this happens, okay? So a system of equations is more than one equation. One linear equation on its own is just a linear equation. As soon as we have a second one, we're calling it a system. And its solution, we can look at it in one of two ways. It's either where the graphs intersect, okay? So it's either the point of intersection or it's the x and y values for which both equations hold true. And if you're not quite sure what that means yet, don't worry about it. You'll understand as soon as we start doing examples. Okay, so what do we mean, first of all, by the point of intersection? So let's just sketch a graph. The equations don't really matter. Just keep in mind that they're linear. Okay, we're only looking at linear equations right now. But everything that we say for linear holds true for all types of systems. So let's say that we had two lines. We have this line. Okay, it's not vertical, there is a slope to it. And we have this line here. Now we could find, actually I'm gonna put those in different colors because I don't want you to confuse either one with the axes. Okay. So let's put the actual lines in blue. So we said this line here, and this line here, two separate lines. Now the solution, this is a system, okay, because we see two lines, it's a system, and the solution to this system is the point of intersection. Now it's important to note that we could have three lines. Now we're only working with two lines. If we had a third line, it would be where all three intersect. So not just where any two intersect, it's where all three intersect. So how do we find the solution to a system? You're given two lines, how do you find the solution? Now, we can use a graph, but a graph is not completely accurate, right? Even if I labeled and marked off this axis here, you know, what if this is at an x value that's a decimal? That's going to be really hard for you to see. So looking at a solution, trying to find the solution to a system by looking at a graph, it's just an approximation. Most of the time, it doesn't fall at integers for x and y. So that's why we don't typically like to use that method, okay? So let's look at a special case, first of all, okay? Let's say that we have two lines so another axis, x and y, and that's a y. But this time our lines are parallel. Now remember that if they're parallel, they have the same slope, okay? So we have a system because there's more than one of these, okay? But they're never actually going to intersect. Now what does that mean? It means there is no solution. There is no solution to this system. So that's one case. So typically, when we have two lines, they intersect exactly once. But in the case of parallel lines, they don't intersect at all, which means there's no solution to the system. And then the last case is if the two lines are the same. And in that case, there's an infinite number of solutions. So that's difficult to show on a graph, so I'm just writing it. So if we have two lines that are the same, there are an infinite number of solutions to the system. Okay, so we already said graphing is not an accurate way to solve a system. So the next way is to try and solve it algebraically. And there are really two different ways to do that. I'll say not always accurate, because if your point happens to be on an integer value for the x and the y, then it can be accurate, okay? So solving graphically is not all that accurate. If we solve algebraically, one of the ways that we can solve is using something called elimination. So let me give you an example of solving an equation solving a system using elimination. So I'm going to start off by giving you two equations. So I'm going to number this as number one as our first example. I want you to notice that for elimination, we put both our equations in standard form. So as soon as you see two equations in standard form, it's actually, elimination is going to be the easiest way for you to solve. You can solve using any method, always. You can always solve using any method, okay? But if both your equations are in standard form, elimination is going to be your easier method. It's going to require the least work. So we have 3x minus 2y equals 6, and 2x plus 4y is equal to 20. Here's what you do. So you start by looking at both equations, and you say the idea is to eliminate a variable, okay? And the way that you can eliminate variables is by adding the two equations together. Now here's the thing, when we look at this and we try and add the two equations, so remember 2x plus 4y is equal to 20. So if I add 2x plus 4y to the left side of the top equation, it's the same as adding 20 to the right side of the equation, okay? So we're actually still doing the same thing on both sides. But if I add them in this way, the problem is that I get 5x from here, I get 2y from here, and I get 26 from here. I have an equation with two variables. In order to solve an equation, one equation, I can only have one variable. So I need to be able to eliminate a variable. So what I'm going to do is I'm going to look at the coefficients. So we're going to be talking about this a lot more in the next unit, but the coefficient is the number that comes directly before the variable. We need to make the coefficients match, except one is the opposite of the other. So how can we do this? We can multiply an equation by a number. We can always do that. We can even multiply both equations by a number. So can we multiply either equation by something so that the 3 and the 2 are the same? Now we can, but in order to do that, we would have to multiply both equations by a number. Over here, if we multiply just the top equation by 2, then I'm going to have a negative 4y here and a positive 4y here, and those are opposites of each other. So that would work. So let's do that. And again, it may take one or two examples for you to start getting comfortable with this, but it's not that difficult to process once you get accustomed to it. So what we're going to do is we're going to multiply this whole equation by 2, and you'll see what happens here after we multiply. Please be very careful. The most typical mistake here is that people don't multiply everything by 2. Okay. Now what this does is it gives us a different equation on top, right? And it's okay because it's still an equation. We get 6x minus 4y is equal to 12. We haven't actually changed anything because we multiply both sides by 2. Now our second equation is 2x plus 4y equals 20. And what we're going to do is we're going to add them. Now you are allowed to subtract equations instead. To keep this as simple as possible, I'm going to make it that we always add the equations. But your elimination, you can add, you can subtract, because either way you're doing the same thing to both sides. So when we add these equations, the negative 4y and the 4y cancel. We're eliminating the y, okay? And that's kind of our goal, to eliminate a variable. And what we're left with is 6x plus 2x, which is 8x, and 12 plus 20, which is 32. Now that we've eliminated a variable, we can solve the equation for the variable that remains, and it's not always going to be x. Sometimes it'll be y. And this is going to give us x equals 4. Okay, but this only gives us an x value. Technically, x equals 4, if we were to graph it, it would be a vertical line. And we don't want a line, we want a point. So once we find the x value, we need to find the y value. Now, in order to do that, we plug this back into one of the original equations. Because remember, this x and y will satisfy both equations, okay? So you can choose whichever one is easier. I look at this and I say, okay, let me plug it into the second one. Makes no difference. Again, it doesn't matter. So 2 times 4 plus 4y is equal to 20. And now we just solve. We have 8 plus 4y equals to 20. We can subtract 8 from both sides here. So the 8 went away, and then we have 4y is equal to 12, and I'm actually going to bring that over here. And then we divide both sides by 4. Remember, all we're doing is solving for y. And finally, what that gives us is y is equal to 3. So now we have a solution. X is equal to 4, y is equal to 3. You need to write your solution as a point, okay? So in other words, as a coordinate. Your final solution would be written as 3, 4, and its coordinates, so it's surrounded by parentheses. Some of you in your homeworks, you will use brackets instead of braces or braces instead of parentheses. It matters which you use, okay? So this is coordinate. Coordinates are surrounded by parentheses. And this is it, you're done, okay? So let's summarize what we did. The first thing that we did is we multiplied 1 or both. So we didn't have to multiply both equations here, but sometimes you will. Okay, if we had wanted to eliminate the x instead, then we would have had to multiply both equations. So we're multiplying 1 or both equations by a number that will make the coefficients of one of the variables opposites. Opposites meaning 4, -4, 3, -4. Sorry, 3, -3. Okay, the second thing that we did, so let's just go back and look. So here we did the multiplication, right? This made the -4y. It made the -4 and a +4 in front of the y, okay? The next thing that we did is we added the equations. Now, when do you subtract? You would subtract if these have been exactly the same. So if this had been a +4y, you could have subtracted the equations instead, and that still would have eliminated the y, okay? And we might come up with something like that at another time where I can show you exactly what we mean. But if we had multiplied by -2, for example, we would have had -6x plus 4y equals -12, and you would have subtracted, okay? If that confuses you, don't worry about it. Just go back to what you were thinking before. Once we did that, we added the equations. And the purpose of this was to eliminate a variable. If you do not eliminate a variable, then you didn't do the first step correctly. Okay, you multiply by the wrong numbers. The next thing that we did is we solved for the variable. Okay, so what this did is we solved for the x, we got an x value, but remember, you need to find a point. So what we need to do is we need to solve for the other variable by plugging this into one of the original equations. I like to plug it into the original equation just in case you made a mistake somewhere here, okay? This helps you find the remaining variable. I should note that you don't have to find the remaining variable this way. You could just use elimination again, except eliminate the other variable. So make the other coefficients opposite of each other. And the purpose of this is to find the remaining variable and it's because we have to find a point. So we need both an x and a y. And again, we mentioned this before, but it doesn't have to be the variables x and y. It could be m and n, it could be q and r, it doesn't matter. And then our last thing is to write our answer as a coordinate. So you must do this. A lot of people miss this last step. I will take off points for missing this last step. Okay, just a half point, but it's still points that you are getting taken off for no reason. Okay. Okay, let's take another example so that you can see it work in other ways. Okay. So I'll number this 2 as our second example. Let's say that we have 4x plus 3y is equal to 10, and 2x plus y is equal to 4. Now notice that none of these are opposites yet, right? We have a 4x and a 2x, 4 and a 2, and a 3 and a 1. Remember, if there is no coefficient, the coefficient is 1. Okay, so they're not the same. So we have to figure out what equation can we multiply by something to make the coefficients opposites. And let's say you have to decide what you're going to eliminate. Easiest way to decide is look at the coefficients and make sure that they're multiples of one another. If they are, that makes it much easier because then you only have to multiply one equation by something. And it turns out that it's just as easy to eliminate the x as it is to eliminate the y. So let's do that since we did the y the last time. How do we eliminate the x? Well, if we take the second equation and we multiply it by -2, okay? Because remember, if this is a 4, this needs to be a -4. So if we take this and we multiply by -2, only the second equation, you don't have to multiply both equations, then what you're going to notice is that our top equation stays the same. We didn't do anything to it. So we get 4x plus 3y equals 10 at the top. And then at the bottom, we get -4x minus 2y is equal to 8. So remember, be careful. -8. The most typical mistake here is that people forget to distribute to the other side of the equal sign. Okay, so if you have to, write it on both sides. This eliminates the -4x. We're adding them. We get 3y minus 2y, which is just y. And then 10 plus -8, which is 2. So this was nice and easy. We didn't even have to solve for anything after this because it's already solved for y. Okay, which is one advantage of eliminating the x. Now I want you to note that if we had multiplied by +2, then this would have been 4x. And in order to eliminate the x's, we would have subtracted the equations. So if you're comfortable with that, feel free to do that. If not, then always just make it opposites, and that way you always add. Okay. Now remember, this was part A, the equivalent of part A. Then we added. That was part B. Part C is already done for us. Okay. So now we're up to part D. We're going to take this y equals 2 and we're going to plug it into one of the equations. And I would just look at both equations and see which one is easier for you. Since this one, the y is already by itself, we don't have to do any multiplying, I would plug into the second one, but it makes no difference. So we're going to take this, and I put an arrow here. We get 2x plus 2 is equal to 4. So we're plugging this in. Okay, it could be to either equation. And if we solve this, we can subtract 2 from both sides. We get that 2x is equal to 2. Sometimes that happens for no reason. Sometimes it happens multiple times for no reason. And then our final step is to divide by 2, right? And that gives us what x is equal to. Now remember, we get that x is equal to 1, but our final answer has to be written as a coordinate. Make sure that you put things in the right place, right? Your x comes first. And actually, I say that and I messed it up in the last one, so I'm going to go back and correct that. So I said 3 comma 4, right? But our y value is 3. So you can see that it's so easy to make these mistakes. I mean, I've solved hundreds of systems and yet still sometimes I make that mistake. So our final answer here was 4 comma 3. Not 3 comma 4. Okay, so be careful about that because you could see that was a mistake I made, which means it's likely going to be a mistake that you make, okay? Because I'm human and you're human, at least as far as I know. Okay, again, if we had eliminated the y, if we'd wanted to do that, we would have just multiplied this equation by -3 and that would have been fine, okay? Okay, let's take another one. 3x minus 5y is equal to -2. And 2x minus 3y is equal to 1. Okay. Okay, so we're going to look at these again and we're going to say, okay, how can we eliminate one of the variables? Now, if you notice, these are not multiples of each other, right? 3 is not a multiple of 2. 5 is not a multiple of 3. Because of that, we're going to have to multiply both equations by different numbers, okay? So you're looking for what can we multiply the first equation by and the second equation by in order to get the same value for both. And if you're really stuck, just multiply by the opposite. So again, let's say that we want to eliminate x here, okay? You could eliminate y. There's no preference. Doesn't matter. It's just what kinds of numbers you're working with, okay? But let's say that we want to eliminate x. In order to eliminate x, we need these to be opposite numbers. Okay. How do we do that? It turns out that if we multiply the first number, the first equation by 2, and the second equation by a -3. So notice I say, if you're stuck, multiply by the opposite numbers. So if this is a 2x and this is a 3x, multiply the bottom equation by 3 and the top equation by 2, and just make sure that one of them winds up negative. Okay. If we had wanted to eliminate the y, we could have multiplied the top equation by 3 and the bottom equation by -5. Okay, or vice versa, -3 and +5. Okay, so if that was what you were thinking and that was going through your head, that's absolutely fine. Okay, so what do we do next? Now we just actually do the multiplication. So we get 6x minus 10y is equal to -4. And then we get -6x plus 9y equals -3. Okay. And we're adding. So the 6x minus 6x goes away. And -10y plus 9y is -y equals -7. So we want a y, we don't want a -y. So now we solve for y. We can do that by dividing by -1. And this gives us y is equal to 7. So we're going to come over here. Okay, and let's just note things that we're doing. Okay, so we start by multiplying equations. And I'll say by number so that you don't get confused. Then we add and solve for y. Then we plug in, which is exactly what we did up here, right? We multiplied, we added, we didn't have to solve for y because it was always already solved for y, and then we plugged in. So again, you're going to choose one of the equations to plug into. I don't think that there's one that's better than the other, so let's just take this 2x minus 3y equals 7. And the only reason I choose certain equations is I just take the smaller numbers because the multiplication is easier. Okay, so we have 2x minus 3 times 7 is equal to 1. That gives us 2x minus 21 is equal to 1. You can add 21 to both sides. That gives you 2x equals 22. So I'm just going to put an arrow here, just so that we have more room. And then you divide both sides by 2. Which gives you x equals 11. And then we have to write it as a coordinate. So remember, be careful, because I've made this mistake already. Our coordinate, the x value is 11 and the y value is 7. And that's our answer. Okay, let's do another example. So what we have 4x plus 3y is equal to 2, and 8x plus 6y is equal to 4. So again, we need to eliminate a variable. 6 is a multiple of 3, and I kind of want to eliminate y because we haven't done that in a while. So let's eliminate y. And what we can do is we can multiply both equations. We can multiply the top equation by a -2. Okay? We don't have to multiply the bottom equation by anything. So this gives us -8x minus 6y is equal to -4. And then on the bottom we have positive 8x plus 6y is equal to positive 4. Okay, I want you to notice something. If we add these two equations, everything cancels on the left, which means we have a 0. Everything cancels on the right, which means we have a 0. Now, if you remember, we talked about this a little while ago. We have 0 equals 0. This is a true statement. We have no variables left, but 0 is equal to 0. This is saying it doesn't matter what you plug into y. It doesn't matter what you plug into x. these equations are always going to yield the same answer, okay? So that means that there are an infinite number of solutions. This is the same line. This is what it looks like. If they were parallel lines, then you would have gotten something like 1 equals 0. Okay, remember we said if you get a false statement when you solve, that means that there are no solutions. Here, this is a true statement. So this is one of those cases. Okay, I'm going to do one more, and then we're going to do systems of equations with substitution, okay? So what I want to do is take one where we have fractions, just to mix things up a little bit, make it more exciting for you. We have 1/2 x minus 1/3 y is equal to 2. And then we have 1/4 x plus 2/3 y is equal to 6. And remember, that's a 2 over 1 and a 6 over 1. Okay, this is messy, right? So in order to work with this, we don't want to have to deal with fractions. So clear your fractions, get rid of them first. Remember, you're multiplying by the lowest common denominator. So here, 3 is not a multiple of 2, so we add 3 to this, and we get 6. 6 is a multiple of 2, so we're going to multiply both equations by 6. Sorry, both sides by 6. Here, we're looking for a common multiple of 4 and 3, so that's going to be 12. And let's see what happens. So here, we're clearing the fractions first. Clearing is the same thing. When I say that, I mean get rid of. So I'll put those two new equations down here, excuse me. So 6 over 2 is 3. So 3x, 6 over 3 is 2. So minus 2y is equal to 12. Don't forget to distribute to every single part of the equation, right? Both sides. 12 over 4 is 3, so we get 3x. And then we have 12 times 2/3, or 24 over 3. That's an 8. And 12 times 6 is 72. Okay, so now we have to eliminate a variable. We got rid of the fractions, now we have to eliminate the variable. This is a case where you could subtract and it saves you a step. Now remember, I said I wasn't going to do that we would just always add, but it would be perfectly fine for you to subtract. But let's make it so that it works for us. We can multiply either the top or the bottom equation by -1. And what that'll do is it will make one of these +3 and one of these -3. So let's just multiply the top equation by -1. It's up to you which one you do. Okay, so that's going to help us eliminate the variable. First, we cleared the fractions. Now we're eliminating the variable. So we get -3x plus 2y is equal to 12, and the bottom equation stays the same. And now we can add these. The x goes away. So 2 and 8 is 10. And 12 and 72 is 84. Okay, I'm sorry, I wish that these would have wound up as better numbers, but they didn't, and that's okay, because then we're getting used to dealing with numbers that aren't so nice. Okay, and typically we would leave this as 84 over 10. okay? The only thing that we would do is we would reduce it to 42 over 5. But we kind of don't like that because that is a fraction, and then we're dealing with lots of fractions. So if you'd like, and this is perfectly fine, we can change it to 8.4. And that's particularly okay here because 8.4 is an exact decimal. And then we're going to plug in. And you could plug into one of these equations after you cleared the fractions. That's okay. Let me put that in black for you. So we get y is equal to 8.4. And that's okay to do because it's still accurate. And then we're going to plug it in. And you could plug it into either one. Let's plug it into the 12 because it's smaller numbers. So we have 3x. When I say plug it into the 12, I meant the first equation. Minus 2 times 8.4 is equal to 12. That gives us 3x minus 16.8 is equal to 12. We can add 16.8 to both sides. Which gives us 3x is equal to 28.8. We divide both sides by 3. And we get that x do not leave it as 28.8 over 3, okay? You shouldn't do that because you should never have a decimal and a fraction. So this one, it's unfortunate, but you're just going to have to divide by 3 and get an actual number. You wouldn't have had to do that if you left it as a fraction, but then it would have been very hard to work with. And actually, I think that we do get a perfect. We get a perfect decimal, actually. It worked out. So we get x is equal to 9.6. That's our final answer. And again, don't forget, write it as a coordinate. Our coordinate is 9.6, comma, 8.4. And that's it. Okay. Okay, let's go over how to solve it by substitution. It's actually not that difficult because a lot of the work is kind of done for you already. Okay, so we solved by elimination. Let's do it by substitution. And again, you can always solve in either way. It's just that when you're doing elimination, you really want both your equations to be in standard form. So if one of them isn't, then what you're going to do is you're going to put it in standard form. Okay. So if we're solving by substitution, typically you're going to do that when you have an equation that's solved for one of the variables already. So let's say that we have 2x minus 3y is equal to negative 6. And we have y is equal to 3x minus 5. Okay. So the first thing that you want to do is you want to make sure that at least one of the equations is solved for one of the variables. And that's already done for us here, so we skip that step. Right? The second equation is already solved for y. Whereas for elimination, again, you want them in standard form. Okay. So now what we're going to do is we're going to substitute. So this is saying y is equal to 3x minus 5. So what we're doing is we're saying take this 3x minus 5 and plug it in for y in the other equation, which gives you 2x minus 3, and instead of y, we're going to write 3x minus 5. And I'm going to actually put this 3x minus 5 in red so that you can see where it's coming from. This 3x minus 5 came from the y equals 3x minus 5. So I'm going to say substitute the variable for what you found in the other equation. Okay, and then you're just going to solve for the variable. So notice, again, I may have said this already, but now we have one equation and one variable, and we can solve that. So we're going to distribute this 3, get rid of parentheses first, right? We get 2x minus 9x plus 15 is equal to 6. 2x minus 9x is negative 7x plus 15 is equal to 6. You subtract 15 from both sides. Sorry, equals negative 6. It's good I caught that. And I've seen people do this all the time where they just copy something incorrectly. Okay, so what this gives us is negative 7x is equal to negative 21. I try and make the numbers nice for you, okay? When I put this on tests or quizzes, I really try to make it so that you get numbers that are integers as your final answers. So I try. We divide both sides by negative 7. And that gives us x equals 3. And then we need to solve for the remaining variables. So again, you could plug it into either equation, but it kind of makes sense to plug it into the one that's already solved for the other variable. Okay, so we're going to plug it into y equals 3x minus 5. So the nice part of solving by substitution is that your last step is so much simpler because it's already solved for your other variable. So our y is equal to 4. And again, you're writing your answer as a coordinate. So it's 3, 4. Okay, so let's just write what we did. So we solved for the variable, then we plug it in. And I'm just going to say into one of the original equations, but again, it makes sense to plug it into the original equation that's solved for the variable already. And finally, you're writing your answer as a coordinate. because we're looking for a point of intersection. And this is saying that if we graphed the lines 2x minus 3y equals negative 6 and y equals 3x minus 5, this is the point at which they'll intersect. Okay, let's take one more example. I'm going to take one that is not already solved, just so that you see what it would look like. So let's say that we have the equations 2x plus 3y equals 5. And we have x minus 2y is equal to 6. So these are both in, I put it in red. I meant to put it in black, but it does matter. This is an example where we could use elimination, okay? But it's also so easy to solve one of the equations for x that we could use substitution too. Kind of up to you. So we're going to solve it using substitution because we've already done a bunch of elimination. So first we add 2y to both sides. It makes the most sense to solve for x here because x is already by itself. And that gives us x is equal to 2y plus 6. Okay, so what does this give us? This gives us 2x plus 3y equals 5. You don't need to rewrite it this way. I'm doing it for your benefit. Okay, and then we can substitute. So substituting means that we are taking this 2y plus 6, which is equal to x, and we're going to replace the x in the first equation with 2y plus 6. We're going to put it in there. So what does that give us? 2 times, and instead of x, it's going to be 2y plus 6. Plus 3y is equal to 5. So notice we have one equation, one variable. We only see the y in here. And now we just solve. So we can distribute. We don't distribute to the 3y. That is incorrect. Okay, you distribute to the parentheses. And this gives us 4y plus 12 plus 3y is equal to 5. Combine like terms. 4y plus 3y is 7y plus 12 is equal to 5. Subtract the 12 from both sides because we need to get the y by itself. We get that 7y is equal to negative 17. Sorry, negative 7. Okay, divide both sides by 7. And our y is equal to negative 1. So now we found our y. Now we're going to plug in. So where do we plug it in? It makes sense to plug it into an equation that's already solved for the variable. So this would be considered one of the original equations. We just wrote it in a different way. So we're going to say, okay, x is equal to 2 times negative 1 plus 6, which is negative 2 plus 6, or x is equal to 4. And so our final answer is, be careful, x is 4, y is negative 1. Okay, so in this first step, we're solving one equation for a variable. Substitute. Solve. Plug in to one of the original equations. Okay. It should be noted that if you have two equations, solve for the same variable. So if we had, let's say, x equals 2y plus 6, and we had another equation, x equals 4y minus 2, okay? You would just set the two equations equal to each other in order to get the y. You're still doing a substitution. It's just that because each one is solved for the same variable, you can set the two equations equal to each other, okay? And you're going to write your answer as a coordinate. Okay, so again, everything could be solved using elimination and substitution. For elimination, you really want both to be in standard form. For substitution, you want one equation solved for one of the variables. But you can, if we had been given this, we could have put this equation in standard form by subtracting 2y from both sides. Okay, so you can use either method. This is it. For our next video, we're going to talk about applications. How do we use this in the world around us? So stay tuned.